Hello guys, welcome to Dan's IT Network. And for today's video, we'll talk about spanning tree protocol. Well, it's just a basic understanding for beginners. Okay, so a spanning tree protocol is essential on a network, especially if we have a multiple redundancy. Okay, when I say redundancy is we have a multiple paths. Okay, so for example, here on the network design, let's say if this PC wants to communicate to this computer in here, then it can go into many directions. Okay, it can go on this direction one, all right, and it can also go on this direction. Okay, and good thing about having a redundancy link is it serves as a backup. All right, like for example, if this port goes down, all right, then we do have a backup link. All right, but the disadvantage in the redundancy, if the STP is not enabled, all right, and we'll be having a problem on the network, okay, because the data packets will keep looping back, okay, on this portion, okay, until it will create a broadcast storm, all right. So until it will not reach the destination, and that is not good, okay. So if we have a multiple redundancy, we need to enable the spanning tree protocol. All right, and the good news is the spanning tree protocol is enabled by default on every switches. Okay, they are on by default. All right, and let's try to ping first. All right, so I'll try to ping from this PC to this computer. Let's see if it will work. Okay, so command prompt, and I'll try to ping the computer. Ping 192.168.1 dot, I'm sorry, that's 1.200. Okay, and as you see in here, that's we are receiving a reply. All right, and it's good. Okay, so how about then, um, let me go to the next slide. So on this network design, all right, the um, STP is disabled. All right, so I disable the STP on every switches. So I disable it on the switch one, switch three, and the switch two. And to disable the spanning tree protocol is you just have to go to the global config mode, okay, and then type the command no spanning dash tree VLAN one, okay, on every switches, and it will disable the span tree. And as you can see here, that all of the links are forwarding. All right, and then if we'll try to, let's say, ping, all right, I'll ping from this computer to this PC over here. All right, let's try to ping desktop, command prompt, and let me try to ping 192.168.2.200. And as you can see now that it is having a hard time, okay, in the reaching the second computer. Okay, all right, well, it is because the STP is disabled. All right, and we have a multiple redundant link. All right, so the packets don't know where to go because they are all active. All right, they keep on looping and looping. Okay, they are like debating, all right, which one should it go, all right, then until the network will shut down and it will create a broadcast storm. All right, well, to fix this, all right, well, what we can do is we can try to delete one of the ports, okay, well, to make it like a single path. All right, so there is no redundant link, so it will try to ping this time. Well, definitely that this will work, okay, as you see. But the disadvantage of this is if this link goes down, all right, then we don't have a backup link. All right, so that is why if we are using multiple redundancy or redundant link, is we need the help of STP. Okay, all right, so let's go back here. All right, so span and tree protocol, STP. Okay, this is the first STP on a Cisco CCNA. It's the original one, classic, and the standard one, and the standard series of STP is the IEEE 802.1D. Okay, and it's running STP instance for all VLANs. Okay, and the port states on the STP are number one, disabled, blocking, listening, learning, and forwarding. When we say disabled, those these are you know this cannot send and receive a spanning tree messages. Okay, when I say spanning tree messages, these are the BPDU. Okay, or the bridge protocol data unit. So these are frames that are exchanging between switches to ensure that only one path exists. All right. So BPDU is spanning tree messages. So disable, so it cannot learn also MAC address, and it cannot forward any frames because it's disabled. All right, and if it's blocking, all right, and then it cannot, you know, send a STP messages, but it can receive though. Okay, it cannot learn a MAC address, all right, and it cannot forward traffic, all right. And if it's listening is it can receive and send STP messages, those BPDUs, but it cannot learn MAC address and it cannot forward data packets. In learning, it can send and receive STP messages. It can learn MAC addresses, but it cannot send data packets. But in forwarding mode is this can send and receive STP messages. It can learn MAC addresses, and then it can forward data packets. Okay. All right. Well, how is the STP working on a network? All right. So these are the three switches. Okay. Well, if the STP is enabled, they are actually talking to each other. Okay. Using STP messages, which is the BPDU. All right. They try to talk to each other, and we have here a four-step process. Okay, for STP. So since they are exchanging messages, all right, using BPDUs, they're trying to vote which one of them should be the root bridge. Okay, so as you see in here, number one process, it will assign and select the root bridge, and to be a root bridge, it needs to have the lowest bridge ID. Okay, but every switches by default, they do have a 32768 bridge ID. All right, and then if we will add the VLAN 1, okay, since they are on the default VLAN which is 1, we'll add the 32768 plus 1, it will become a 32769. So all of them um, has this default 32769. Okay, so STP cannot decide then which of them is the root bridge, or we can say if it's a root bridge is the boss switch. All right, boss switch or king of the switch, we can say that. All right, so the next thing that the STP will do is it will try to look for the lowest MAC address on each switches. Okay, and I already written down the MAC address on each switches. Okay, switch 1, switch 2, and switch 3. Okay, and they are in the form of hexadecimal. All right, and it's kind of hard to understand which one of them is the lowest. All right, unless is you do have a basic understanding in hexadecimal. All right, well, I do have a separate tutorial on the how we can understand hexadecimal, and if you want to convert it to a decimal. Okay, so that you do know how to uh, see if which one is the lowest or the highest. All right, and I will post the link on the description below for you to see. Okay. All right, and let's say for example, if the STP, let us pretend that this is the boss switch or this is the root bridge. Okay. All right, so um, if it is a root bridge, it should have a all ports should be on the forwarding state. They should be active. All right. Okay. And then the second step is after selecting the root bridge, all right, it will assign a root ports. So root ports can be found on the other switches, like on the switch 1 and switch 2. So it will assign which port, okay? It should be the closest ports to reach the root bridge. All right. So on this switch, the closest port to reach the root bridge is the gigabit 0/2, which is this one. Okay, gigabit 0/2. So we can tell then that this is the root port. All right, but we're not that sure. Okay. And also on this switch one, we can also tell that this is the root port. But definitely later on is we will try to check them one by one, which one on all of the ports are the root ports. Okay, it's because by selecting the root ports, the STP also consider the port cost, okay, which is the port cost. Let's say around here, this is a gigabit port, all right, so it's a gigabit to a gigabit. The port cost on this is equal to 4, okay, so the lower the better, and the lower the fastest, all right, since it's gigabit. And this is a fast Ethernet. Okay, the port cost in this is 19. So if it is a fast Ethernet, this is a full duplex, and this is 100 megabit per second. So how do we know? All right, so I'll open this switch. I'll go to the command line interface, hit enter to get started, and then enable. And then I'll type here a show interfaces, and then F0/4. Okay, and scroll up, and you'll see here that this port is a full duplex. It's 100 megabit per second. Okay, so it's 100 megabit per second, so it's 19. So this is 19, this is 19, 19, and this is port cost is 4, and port cost is 4. Okay, all right. And a third step is the STP, or the spanning tree protocol, will assign a designated port, or the forwarding ports. Okay, so every switches on this network, they should have a designated ports, meaning a forwarding ports. All right. So later on is we will identify them. All right. But again, if it's a forwarding ports, it is an active port. It is forwarding, sending a traffic. All right, and it's receiving and sending BPDU messages, and it is learning a MAC address. All right. And the last step that STP is it will assign number 4, so it will assign a non-designated ports, right? So when we say non-designated ports, these are like the alternate ports, all right, or the blocking ports. So it is obvious in here that the F0/2 is the blocking port. All right, so when we say blocking, so it blocked the network traffic, all right, on this network design. Okay. All right. So now, our goal now is to identify which among the switch is the root bridge. Okay, and we need to identify what is the status on their ports. So each and everybody. All right. So we'll identify which is the root ports. Okay, which is the designated and the non-designated. So we'll start first on the switch one. So I'll open this switch one, and I'll hit space, okay, to get started, and then I'll type here show. So I am under the privilege mode. Okay, so I'll type here show space spanning dash 3. Okay, all right. um Let me spread this for you. All right, so as you can see in here, so this is the previous command that we input, show spanning tree. All right, so we are under the VLAN 1, which is the default VLAN. Okay, and the spanning tree is enable. All right, and in here is it gives us the information about the root bridge. So when we say root ID, this is the root bridge. Okay, but this SW1 is not still not yet the root bridge. So it's just that it gives us the information. So the root bridge is has the MAC address of 000D.BD43.4623. All right, and it has here a priority number of 32769. So why it is 32769? I told you a while ago that the default priority bridge ID of each switches is a 32768, right? And then plus the VLAN ID number, which is VLAN 1, the default one, is will become then 32769, all right? Okay. And then this bridge ID, okay, so this is the MAC address on this switch 1, all right? So as you've seen here, the MAC address on the bridge ID is not matched on the root ID. Okay, well, it's because this is the MAC address on the root bridge, and this is the MAC address on this switch one. Okay, and if they are the same though, then definitely is we are on the root bridge. Okay, all right, and if we'll try to look on the status on the port on the switch one, all right, so the F02 is on the alternate port, all right. When we say alternate, this is the non-designated port, and BLK, this is stands for blocking, all right, and the cost is 19. So I um, mentioned to you a while ago that if it's a fast Ethernet, it's 100 megabit per second, and it's a port cost is here is 19. Okay, that's why it's 19 in here. Okay, so let's take a look. So this is the fast Ethernet 0/2, and as you can see that it's a color orange, so meaning that this is a blocking status. All right, so let's put this as the non-designated port. Okay, let's label them one by one, and let's keep looking. Let's check the fast ethernet 0/3. What's the status? So fast ethernet 0/3, it's the designated port, and it's forwarding. Okay, forwarding port, and the cost is 19. Okay, so we'll assign this one then as the designated port. Okay, all right, and let's keep looking though, one more. So gigabit 0/1, it says in here that this is the root, okay, the root port. So as you see in here, roll, this is the root port, and the state is forwarding. The cost is a 4. Okay, and in here, this is the priority number though. So 128, and then the priority number is the this 25. All right, so this is the root port. So you need to label it root port, and we'll label this down. All right, okay, and I'll close this. And I mentioned a while ago that if it is our root port, is this closest port, to reach the root bridge, right? So in order for us to locate the root bridge, okay, we need to go this way, all right, to this switch 3, because this switch 1 is telling us if we want to see the root port, or I mean root bridge, okay, we need to go to this direction because this is the root port. Okay, so let's open up this switch number 3, hit enter, and then I'll type here enable, and then I'll type show space spanning dash 3, same command, and then it gives us the same message though, VLAN ID default 1. Okay, span tree is enabled, and it also gives us the information about the root bridge. Okay, its MAC address over here, and also the priority number, and this bridge ID. This is the information or MAC address of the switch 3. Okay, and by checking on the status on the port, the gigabit 0/1 is the root port. Okay, it's a forwarding. All right, as you see here, role report. Okay, state is a forwarding, and then cost is 4. So why it is 4? It's because it's a gigabit port. All right, so it's a gigabit port cost is 4. Okay, all right, and the gigabit 0/2. This is the designated port, and it's a forwarding, and the port cost is a 4. So let's label them. Okay, so gigabit 0/1. This is the root port. Okay, and then gigabit 0/2 is the designated port. All right, so you notice that every switches though they should have a one designated port. Okay, so we will try to take a look on this switch number 1. It has a designated port over here. Okay, since it's connected to a computer. Well, the computer doesn't really understand STP though. That's why it's automatic that this F0/3 is a designated port. All right, and then this is a root port, and this is a non-designated port. Okay, and in here, this one is the root port, and the other side, gigabit 0/2, is the um, designated port. All right, so let's keep looking. So since this is the root port, we need to go to this direction. So let's go to the switch 2, and I'll go to the command line interface, hit enter, then I'll type here enable, and then I'll type show space spanning dash 3. Okay, and let me spread this. And as you can see in here, that it tells us that this is the root bridge. Okay, why? It's because the MAC address are the same as you see. Okay, and also it tells us that this bridge is the root. Okay, so they have the same MAC address, so definitely then that this is the root bridge or the boss switch. Okay, and priority number 32769, 32769. And by looking on the port, okay, all of the ports on the root bridge are, they are all forwarding. Okay, so forwarding, 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 and designated. Okay, designated port, designated port, designated. All right, so these are the costs 19, 19, and then 4. Okay, if we'll try to check then. All right, so this is the switch 2. So this is forwarding, designated port, and another designated port. Okay, all right, there you go. So this is the root bridge then. So you might be asking though, okay, so how come on this switch 1, you mentioned a while ago, right, that the root port should be closest to the root bridge, right? Which is this switch 1, the F0/2, this should be the root port because this is closest to the root bridge. Well, that is a good question, right? Well, the answer is actually the STP is also basing and relying on the port costs, all right? On the port cost. So as you seen here, the port cost on this fast Ethernet is the 19, all right? And while in here, all right, it's using the gigabit port, the port cost is just 4. So the lower the better, and the lower the fastest one. Okay, so the spanning tree decide to put this F0/2 as the non-designated port because it sees that this is the worst, maybe a port cost or the worst priority number on a bridge ID. All right, so that is why the STP assign it as the blocking port. All right, so there is like STP um, like balancing the load balancing, all right, um, to make it work just fine, right? Okay, but anyway though, this is the blocking port then, all right. So another question though, what if I will just assign this switch 3 as the root bridge? Can I do that? All right, well definitely yes though. If we want to assign this SW3 as the root bridge, then we can manually lower down the priority number, all right? Or we can just assign this as the root primary or primary, okay? How can I say it? Primary. Okay, so let's go on this SW3. Okay, so I go here to the, I'll type here COMT to go to the global config mode. And if I want this to be the root bridge, I can type this command. So spanning dash 3, okay, and then space question mark. So in here, we'll be using this command VLAN, all right? I'll type VLAN and then space question mark. So ask us to the VLAN range. Well, we are on the VLAN 1, default VLAN, so I'll type here 1, okay, and then space question mark again, all right, and then it tells us we can use the root command, we can use the priority, all right. So let's say we want to use this root though, so I'll type here root, okay, and then the space question mark, then I can type a primary, okay, so primary. So if I will hit enter on this, what will happen is the switch 3 will become the root bridge, okay. But on this tutorial, Let's not use this root then. Let's use the priority to make it more exciting. All right. So I'll type again question mark in here, and let's use the priority. All right. So I'll type priority, but it's much more challenging. Okay. So priority and then space question mark. So it wants us to enter from 0 to 61440 and bridge priority in increments up 4096. So it should increase every 4096. All right, so we can choose that. So if we'll try to use the calculator, okay, so 4096 plus 4096, okay, the next one that we can input is 8192. But since we're dealing about the lowest though, how about if I'll just use the 4096 as the lowest one? All right, let's do that. All right, so control C, and then I'll save the configuration, and let's see though if the STP elect this switch 3 as the root bridge. All right, let me try to fast forward the time. Okay, and let me open this switch 3, and then I'll type here show space spanning dash 3. Okay, and I'm gonna spread this. And as you can see in here that the switch 3 became the root bridge. All right, so it has the same MAC address, and it shows in here that this bridge is the root, and also the priority number was changed into a 4097. So you might be wondering why it is 4097, wherein a while ago we only input 4096, all right? So 4096 plus the VLAN extension ID number, which is number 1, okay? It will then equal to 4097, okay? So 4096 plus 1 equals to 4097. Remember that, all right? Okay, and definitely though you can try to play around with this switch. All right, if you want this switch one to be the root bridge, okay, then you can lower down the bridge ID priority number, or you can just select it as the root primary. If you like this video, please do subscribe to my YouTube channel, Dance IT Network, to get more updates about Cisco CCNA. And if you have any questions, suggestions, or requesting for any video tutorial, then you can email me, danceitnetwork@gmail.com. Thanks for watching. Bye.